Here's a quick tutorial on how to use threads in Python. So I have a folder open in VS Code, and I have one file in this folder, and we're going to start coding right here. So I'm going to import two things. These are both built into the Python language. First one's threading, and the next one is time. And then down here I'm going to define a function. Make this larger. I'll define a function called one, and just really simple print statement. Now, we can call this function with a thread by doing this. So you make a new thread, we can just call it great variable name t1, why not? And it's just going to be threading.thread, then you pass in target, which is just the name of the function, just like so. And then now that you have this t1 variable, you can start the thread by doing t1.join. No, t1.start, sorry, excuse me. Okay, so in the terminal here, make a new terminal. Make sure, it's your normal terminal. You can do ls, pwd, all that stuff. We're going to run this file. So you can just do python example.py. And as you can see, very, very simple. We just called the one function by running a thread. So the next thing I want to demonstrate is how this is actually running separately from the traditional one line at a time. So maybe up until now, writing code, your understanding of what code is being ran in a file is one line at a time, right? So this one, next. If I put a print statement down here, just saying what line we're on, right? And then I'm going to change this function to run on a loop. So just I guess we'll do while true. We'll print this. Let's sleep for 1 second, and then we'll just go forever. Just going to keep going. So if I run this code, right, let's see what happens. You can see that line 11 ran first. Hello one from 1 ran first, right, because it got called first, and then line 11 ran after. But then line 11 obviously never ran again, but 1 is still running, so that's why this Python program didn't exit until I stopped it with Control C. So if I switch this around, just make the sleep before, we should expect what do you think is going to happen with the order of print statements? As you can see, sure, we called this function first, but it slept, and then it printed something. And in parallel with this sleep on line 7, I guess this is now line 13. Line 13 ran. So as you can see right here, right? I can even run it again just for demonstration. All right, I stop it. You can see that right here, the order of lines is different, because when you're using threads, you have multiple lines of code running in a file. Okay, so the next thing I want to talk about is locks. So you can make a lock like this. You do threading.lock, and a lock has two states. I'm just going to call it free or acquired. And locks are very useful when you're dealing with threads, so that you can prevent race conditions, you can control the order of when things are running. When we create a lock in Python, the default state is free. So I'm just going to say free is the default. And so in order to change this lock to be acquired, you can just do lock.acquire. And once the state becomes acquired, no one else can acquire the lock until it's freed. So like once it's until it's free, like so. So what I'm going to do is, instead of doing the time.sleep, in here I'm just going to do lock.acquire. So this one function is just going to run forever, and it's going to try to acquire the lock, and then it's going to print hello from 1 after. So let's see what happens now. So I'll change this to line 19, hello, and let's run it again. So as you can see, only this print statement ran, and the Python program is still running because I didn't get my terminal prompt back, and we're stuck. So this is an example of a deadlock, because this thread is trying to wait for this lock to become free, but earlier on we already set it to acquired, and there's nothing to free it. So this Python program is basically stuck. And let's make 2 threads. One thread will release the lock, and this thread will acquire the lock. So we can do def, I'll just make a function called to, great variable names, of course. And make another while loop like so. And we're going to do lock.release. And then in here, we're going to sleep. So time.sleep. Let's just sleep for like 2 seconds. So then down here, I'm going to remove this print statement. That was just for demonstration. I'm going to make another variable here. It's important to get good at multiple cursors. As you can see, I just made a T2 instead of T1. And then the target here is just going to be 2. So now both these threads are going to run. And let's see what happens. So remember, you can free a lock more than once, but it'll just remain in the free state. You can only acquire a lock once, and then once this thread has the lock, no one else can acquire it until it's freed again. So let's go ahead and run this real quick. So it's the main code that we're going to focus on here. So I stopped it, and then now let's restart. So as you can see, every 2 seconds, the one function is running because the one function tries to acquire the lock. Once it has it, it runs the print statement, and then it tries to acquire it again. But we already talked about how if a lock state is already acquired, you cannot acquire it again, so this gets stuck. So gets stuck until the lock is free. And then this waits every 2 seconds. So you see how 2 is actually controlling the behavior of 1. We can even, just for demonstration purposes, at the top of the file, I'm going to import one more thing. I'll import datetime, and then we can just print datetime.datetime.now, just for the date. Do it over here, so it kind of functions as a log. So we're going to print the date just so you can see that it's every 2 seconds it's running. So start again. Yeah, as you can see, 42, 44, 46. What do you think the next number is? Yeah, as you can see, every 2 seconds, 2 is controlling the behavior of 1 with a lock. Very cool. Okay, I'm going to demonstrate how to use events in Python for the last part of this tutorial. So I'm going to make a new file called ttl.py. And in this case, TTL stands for time to live. And just like before, I'm going to just import the same stuff again, like so. And in here, we're going to define something called an event. So like this, I'm just going to call it cancel event. So this event will be set. I'll go over what setting an event and all that means in a moment. But this event is going to be set once we want to cancel something. Okay, and then I'm going to make a function called go to round 1 after delay. So what this function is going to do, or pretend to do, is we're going to go to round 1 after some time to wait. But if for some reason our plans get canceled, this function will also react to this cancellation event. So I'm just gonna do like wait seconds. It's gonna have one parameter called wait seconds. This is gonna be an integer, and it's gonna be how long we have to wait before we can go to round 1. So if we didn't have to wait, we're just gonna go straight to round 1, right? Very easy. And down here we'll call the function, just with my very creative variable naming, threading.thread, and then you can pass in target, which is just the function name, right? And then you can also pass in, I'm gonna make it multi-line just so it's a little easier to understand. The second thing that you can pass in is the parameter. So you pass in it like this, args equals, and it's a tuple. And in order for it to be a tuple, if your tuple, right, your thing wrapped in parentheses is one element, you have to put a comma at the end. So that way Python evaluates this as a tuple. Otherwise, it evaluates this as just an integer. I'll prove it to you right now. So if you just run Python, you do 3. See how it evaluates it to 3? But if you do 3 comma, it evaluates it to a tuple. You can even double check this even further. So you can go to type 3, it says tuple. But if you don't do that, int. Yeah, interesting. So you got to make sure, just put a comma at the end if your tuple is one element. So I'm going to start T1 like so. Okay, so this is really easy. I'm not even going to run this code because it's just going to print this. It's just going to print the thing, right? So now let's add some logic here in case we get canceled, in case our event gets canceled. So if cancel event dot wait, so this is going to wait for a certain amount of time to see if our plans get canceled, and you can pass in a timeout, and then we'll pass in wait seconds. So now if the cancel event gets set, this if statement evaluates to true. So then let's just do something in here. Have a print statement like never mind, plans changed. And yeah, pretty straightforward, right? So let's go ahead and run this. So I'm gonna just do print ttl.py. Nice, yeah, that's exactly what I wanted to do. ttl.py, here we go. So it's waiting for 3 seconds, and then it just printed it. So the event was never set, as you can see. So let's set the event. So notice it's going to wait for the event to be set for a certain number of seconds. So if I just do like time.sleep, and then I'll print something like setting event, and then setting event now, and then we can do a cancel event.set, just like so. And I'm going to sleep for 5 seconds. So let's see what happens. What do you think is going to happen? Let's do a quick hypothesis. We're going to wait for 5 seconds, then we're going to set the event. But this only waits for 3. What's going to happen? So 3 seconds pass, it goes to round 1, and then the cancel event gets set. So as you can see right here, this only waited for 3 seconds. No cancel event showed up in that time, so it just moved on. But it showed up later. So what if we change this to 2 seconds? This is going to wait for 3 seconds, right? Because we're passing in 3 on line 15. But after 2 seconds, we're going to set the event. Let's see what happens. As you can see, it set the event first instead of last. And as a result, our function reacted saying, never mind, plans changed. Yes. So what if we run another thread after? What's going to happen? So I'm going to just make another thread down here called like T2. You could even reassign it to T1, doesn't matter. But I'll just call it T2, and let's see what happens. So let's do Python ttl.py. This ran twice because we called the function twice, and both times it got canceled. So one thing you have to realize is that once an event is set, it's set forever. So if you want to reset an event, you have to reassign this to be an event again. So what I'm going to do is I'm just going to make a function called I'll just call it def reset event. This is just total Python demonstration. There's probably a smarter way to do this. If you want to reassign a global variable or a variable that's outside the scope of a function, you have to do this. You have to put global cancel event. This is only if you're reassigning it. If you're reading from it, you don't have to do this. If you're calling a function on the global variable like here, you don't have to do it. So we use global only when reassigning a global variable. If you didn't do this, then it would just create a new variable within the scope of reset event, which is different. It wouldn't mess with this guy. So if you want to reset the event, you set it again to just like that. And so now if you down here we were canceling the event on line 26. I'm actually going to move this up here. So we're going to call set. So we're going to say we're just gonna do a set and reset event. Yeah, what a great function name, right? So it's gonna set the event, and then after it sets it and the associated threads react, it's gonna reset it to just be an unset event, if that makes sense. So I'm gonna call this function down here called set and reset event, and I'm gonna move this print statement to here. So what's going to happen? We're starting T1, wait for 2 seconds, then we're going to set and reset, and then T2 is going to start. So let's see what happens. Ready? So let's run it. So 2 seconds are going to pass. Setting the event now, plans changed. And then you can see T2 didn't react to the cancel event because we reset it on line 13. As you can see, we called this function, right? We called that function reset the event before we made another plan to go to round 1. The absolute last thing I want to cover is how we can use logging to see what thread we're running. So I'm going to just import logging up here. And down here we're going to have a function called logging basic config. The code for this video is in the description. So if you want to copy and paste this, you don't want to type all this out, I'll just go over it real quick. I'm going to change this to info. So logging is another way that you can print text in the terminal when you're running Python. And you can pass it a few options for how you want to format the logs. There's levels. I don't really want to go all the way in depth, but we have the date format here. What this second parameter here is, this is going to be the date. In square brackets, it's going to be the thread name, the level name like error, info, and then finally the message that we pass in. So I'm going to change each instance of print. If you just double click print and then do Control D if you're not on Mac, but if you are on Mac, do Command D. You can highlight each instance of print. Okay, yeah, highlighted all the instances of print, and you can just do logging.info like so. So now let's rerun the same exact behavior that we did earlier, right? We had this. Not much context on timestamp, location, thread name, stuff like that. So let's do it again. And as you can see, we have two different threads, right? Pretty cool. You have your main thread, which is just the normal stuff outside of any like threading code. And the main thread, that log statement happened here because we called it without the threading use, right? We just called this function directly. So that makes sense. Thread 1 corresponds to T1, right? So T1 got canceled, right? Because this got set before 3 seconds, right? 2 seconds passed, then it set. And then T2 waited for 3 seconds again. And this totally matches up, as you can see, right? As soon as the event was set, thread 1 reacted. And then pretty much after we reset the event, thread 2 started. And then 3 seconds later, thread 2 exited. And since it didn't get its plans canceled, it got to go to round 1.